All right. Here we go with part 2 of the unit review. So, starting with question 12, it says the correlation coefficient between the number of AP classes taken and parental income is 0.430. So this is our R. For a student taking a number of AP classes that is 1.3 standard deviations above the mean, we would expect that student's parents to have an income blank standard deviations above the mean. Okay, so this is one of the applications of our correlation coefficient. We're saying that along the x-axis, the number of AP classes, I'm just going to say AP classes, is 1.3 standard deviations above the mean. So it's farther to the right than average. Now, since the correlation isn't one-to-one, it's not a perfect linear relationship, this is where the idea of reversion to the mean comes from. We're going to expect that the parental income is higher than average, but not as high as 1.3 standard deviations, because this and this only have a correlation of about 0.4. So, as usual in stats, when you're not sure, multiply. So 0.43 times 1.3 is going to give us about 0.56. And that's this one. You just pop that in a calculator. Okay, so again, the correlation, if you know how many standard deviations above or below the mean a data point is in one aspect, in one unit, you can predict how far away in standard deviations from the mean the data point is in the other unit by multiplying by the correlation coefficient. Okay, cool. Now for some probability. As many of you noticed, probability of A given B and the probability of B given A, since these are independent events, we can just say that this is equal to the probability of A, or 0.7. And this is equal to the probability of B, or 0.3. Right? That's how we defined independence. If the probability of A given B is equal to the probability of A, the events are independent. If you wanted to use the conditional probability formula, so probability of A given B is equal to probability of A and B over the probability of B. Well, to find the probability of A and B, you would multiply. So in this case, we do 0.7 times 0.3 all over 0.3. And just, algebra numbers, those are going to cancel out. We're left with 0.7. Cool. So for D, I'm actually going to do that before C. So D, the probability of A and B, again, this is for independent events. We're just going to multiply the probabilities together. So probability of A times the probability of B. And in this case, that gives us 0.21. So for C, this is one of the formulas you will actually get on your formula sheet. And the formula for A or B is the probability of A plus the probability of B minus the probability of A and B. Because the probability of A and the probability of B each contain some overlap, right? If they're not mutually exclusive events, they each contain some overlap. So they each contain the same overlap. We're going to subtract that out once, so we're not double counting it. So in this case, that's going to be 0.7 plus 0.3. And then we're going to subtract this 0.21. And we get probability of 0.79. So again, this is just a formula on your formula sheet. You could also use this to come up with that. A bunch of you did this in class in a lot of different ways that worked out. Awesome. Number 14. Data is collected on a college freshman's first semester GPA. And excuse me, the mean is 2.89 and the standard deviation is 0.38. The researcher then discovers that all of the collected GPAs were collected incorrectly and should be multiplied by 0.8 and have 0.5 added. What is the new mean and standard deviation? So this is a unit 1 idea. Any measure of position, mean, median, maximum, minimum, that gets everything. So the 2.89 is both going to be multiplied by 0.8 and have 0.5 added. Any measure of spread, I'm going to label this position, and then spread, you're just going to do any multiplication or division. So we're going to take the 0.38 and multiply that by 0.8. So the new mean should be 0.89 times 0.8 plus 0.5. New mean is 2.812. Why not? And the new standard deviation is 0.304. Cool. For 15, what are the differences between observational studies and experiments? Be sure to address the types of conclusions you can draw from each. So for observational studies, the key here is you're just collecting data without any manipulation or applied treatments. The other big thing is you cannot establish causation. An experiment, you do manipulate treatments. Manipulate treatments applied. I should probably say applied treatment, whatever. And you could potentially find causal relationships. Causal relationship. We're going to get into this as we get into our hypothesis testing, yada, yada. You still want to be very, very cautious about any time you're saying one thing causes another. It's just going to be rare and need to meet a lot of requirements. All right. 16. Target wants to collect some information on its customers. Which of the following situations is a cluster sample? So remember, cluster is all of some. So A says select a random sample of 50 stores and survey every customer at those stores. That's a pretty good explanation or description of a cluster sample. Pick the 50 closest stores to headquarters and survey the customers at those stores. No, that would be called a convenience sample. That is not a good way to get data. I'm going to cross that out for lots of reasons. C, survey every 100th customer at each store. Again, so that's all of the stores. And every 100th customer, that would be our systematic random sample. D, from a list of targets rewards customers, randomly select 500 customers to survey. So that would be closer to a simple random sample, but this would really expose you to some undercoverage bias because people who sign up for target rewards customers might not be representative of all target customers. Lastly, split the list of targets rewards customers into males and females, then randomly select 500 males and 500 females to survey. So this is creating some strata, but still those rewards customers, we're not selecting from the whole population of interest. And it's definitely not a cluster sample. So in this case, A is our answer. Okay. 17. So But I have faith that you will all be able to do this by the end of the semester. So linear regression was performed on a set of data relating the distance of a flight to the fare or the price. Use the table below to answer the following questions. First up, so far, we're not going to use this, and we're not going to use any of these. We are only using this bit of information. We'll get into these, but not yet. Second, what is the explanatory variable? So we can think about this as our X, our input. And that you want to think about the two things you're relating, distance of a flight to the price. It's more logical that the distance of the flight is going to affect the price rather than vice versa. You don't typically go say, okay, I have $500 to spend on a plane ticket. How far can I go? It's usually the opposite. So the other place to check here is if it's listed distance as our variable, that's our explanatory variable, which means the response or the Y is the price. Okay. Regression equation. This value with the variable that has either X or explanatory or the unit, this is always going to be our slope. And this is always going to be our y-intercept where it says constant and then the coefficient of the constant. So our regression equation is, I'm going to do it as the predicted price is equal to 177.215, our y-intercept, plus the slope. I'm not going to write all those digits. I'll say 79 times the distance. And if you used y hat and x for price and distance, that's fine. Just make sure you define them. Okay. So what is the slope of the regression equation? Well, the slope is the coefficient on x or the coefficient on the explanatory variable. So that's going to be 0.079. And the interpretation of the slope in context. So that sentence stem for each additional, and in this case, I'm going to assume it's miles, mile of distance, the response variable, in this case, the price, is predicted to increase by about 7 cents or 8 cents on average. So again, that sentence stem for each additional blank unit of explanatory variable, the response variable is predicted to increase or decrease if the slope is negative or positive by about whatever the slope is on average. You need those words, predicted, about, average. This is a prediction equation. Regression equations don't tell you what will happen. That's magic, not math. This is based on the data we have. The trend would predict this value. You may get a different actual value. Okay. The y-intercept is our 177.215. And the interpretation would be for a distance of 0 miles, the price is $177. I don't know about you. I'm not flying with that airline. I would say this is not meaningful. Or you could say there's like just a base cost. Maybe they average that out like just to service the plane, pay the people, whatever, per customer. It's going to take at least that. Last but not least, R squared. So this is the one a lot of people are still having trouble with. remember, especially on an FRQ, just identifying the value can be worth some, can be worth partial credit. So definitely find it. And then the R squared value of 0.482 means that 48% of the variation in price is associated with the variation in distance. So this one is always the R squared as a percent of the variation in response variable is associated with the variation in explanatory variable. Okay. So 18. This one, it's a little weird as a non-multiple choice question, but I just want you to think about what probability actually means. So in a large group of teachers, approximately 15% will have a cat. What you have to be careful about is this is for, again, in the long run. So if you had 100 people, this doesn't mean that exactly 15 will have a cat. If you have 10 people, it doesn't mean that 1.5 will have a cat, right? It's overall in the long run. So be really cautious about any answers that have really concrete words. Okay. Next up, name the experimental design for each of the following situations. So A, researcher wants to compare the performance of 3 types of pain relievers in volunteers suffering from arthritis. Because people of different ages may suffer arthritis of varying degrees of severity, the subjects are split into 2 groups, under 60 and over 60. Subjects in each group are randomly assigned to take one of the medications. 20 minutes later, they rate their levels of pain. Okay, so this is applied treatment, right? They're randomly assigned to take one of the medications. So this is an experiment. And they're split into groups based on a variable that might affect what we're studying, but we're not actually studying that. So we're not studying how age affects it. We're studying how the medicine affects the pain. So we are blocking to reduce the potential confounding effect of the difference in age. And it is randomly assigned. So it's random. So you might call this a randomized block design. Randomized block design. Okay. Does donating blood lower cholesterol levels? 50 volunteers have a cholesterol test, then donate blood, then have another cholesterol test. So this would be matched pairs. The subjects, the volunteers, are matched against themselves. This wouldn't really be an experiment because nothing is applied. So it's just an observational study. But because we're pairing someone against themselves, that's what we're going to call that a matched pairs design. And that can reduce a lot of bias because you're mostly the same as yourself 20 minutes later. Oh, that was for this one, but you're mostly the same as yourself before and after you donate blood. So there's a lot of variables being mitigated. Cool. See, a group of doctors want to know if people feel more pain after a shot in their dominant arm. They randomly select half of their patients for the day to receive a shot in their dominant arm, and the other half receives a shot in their non-dominant arm. So this is just completely randomized. They didn't block on age, gender, reason for appointment, etc. Just completely randomized. Last but not least, pharmaceutical companies developing new blood pressure medication. They recruit 1,000 volunteers with high blood pressure who are not currently taking any medication. Volunteers are randomly assigned to receive either the current standard of care medication or the new medication, but they're not told which. The doctors and researchers see the labels for the medications as only A or B and do not know which is the old medication and which is the new medication. So this is a double-blind randomized design. So it's double-blind because neither the subjects nor the researchers know which medication is which. They just see A or B. And then in the processing, the A and B can be revealed after all the analysis is done so that there's no bias in how things should or shouldn't turn out. Okay, onward. Costs for standard veterinary services at a local animal hospital follow a normal model with a mean of 80, mu for mean, and a standard deviation of 20. So that's our standard deviation. Draw and clearly label a model for this situation. Okay. Here's our normal curve. Should have given myself a little more room. 80 is going to be right here in the middle. And then at our first inflection point, we're going to have 20 above, which is 100, and 20 below, which is 60. And then go a little farther, and 40. So I'm going by 20 because that's our standard deviation. And we've said it's a normal model. And lastly, over here, we're going to have 140 and 20. And these are all in dollars. Okay. What is the Z-score for a service that costs $68? Right. Z-score is the value minus the mean all over the standard deviation. So our Z-score is going to be our value, 68, minus the mean, 80, all over standard deviation. And so we get negative 12 over 20, which is negative 0.6. So that is our Z-score for a service that costs $68. This means it's 0.6 of a standard deviation below the mean. C, approximately what percent of services cost more than 168? Pretty sure I was supposed to just type 68 again and didn't catch that. So all good, we can still do this. It's just going to be really teeny tiny because 168 is way out here. So this is a normal CDF because we are looking for a percent or a probability. So normal CDF, we want more than 168. So let's put that as our bottom, as our lower bound. And then we're going to put essentially positive infinity as our upper bound, our mean as 80, and our standard deviation as 20. When you pop that in a calculator, you get what might appear to be a kind of big number, but is actually a very small number. If you ever are using normal CDF and you get a value above 1, look to the right because there is going to be an e to the negative something that has to be in scientific notation. There's no way you're going to get more than 1 out of a normal CDF. So that and 80 and 20. So we get 5.42 times 10 to the negative 6. Okay. What is the Z-score for a service that costs $125? So again, 125 minus 80 all over 20. And we're going to get 45 over 20. And we expect a positive value because 125 is greater than the mean. Gives us a Z-score of 2.25. So $125 is 2.25 standard deviations above the mean. And approximately what percent of services cost more than that? So just for fun, since we just got the Z-score, I'm going to use the Z-score. We're looking for a percent. So again, it's normal CDF. And more than 125, well, that has a z-score of 2.25. So I'm going to use my z-score as my lower bound. Then I'm going to use essentially positive infinity as my upper bound. My mean, I'm going to use as 0 because I'm using a standardized score. Now I'm going to use the standardized mean, which is 0, and the standardized standard deviation, which is 1. Popping that in, second vars down to normal CDF. For now, always CDF. And yes, first period, that one table, it's always CDF. So 0 and 1, for now at least. And so that gives us a 0.012, which is about 1.2%. Cost more than $125. Okay, onward. Almost there. 21. In Miss Jacobs' AP Stats class, 68% of all students have a last name that starts with a letter in the first half of the alphabet. So that's going to be event H. 40% are in fourth period, event F. And 75% are either in fourth period or have a last name that starts with a letter in the first half of the alphabet. Are H and F mutually exclusive events? Use probability notation to justify your answer. Okay. So kind of working backwards. Mutually exclusive means that the probability of H and F is 0. That if one happens, the other cannot happen. The probability of both is nothing. It just can't happen. Well, we have the or, and we have the individuals. So we're going to use that probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And we're just going to fill this in and then use algebra to solve for this. So think about A as our H and B as our F. So the probability of having a last name that starts with a letter in the first half and it being in fourth period, or being in fourth period, or being in fourth period is 75%. The probability of just having a last name that starts with the letter in the first half is 68%. The probability of being in fourth period is 40%. And then the probability of both having a last name in the first half of the alphabet and being in fourth period is what we're looking for. So we'll get 0.75 equals 1.08 minus P, H, and F. And we'll subtract 1.08 from both sides. And we get 0.33. Negative 0.33 is equal to negative that probability of H and F. Since they're both negative, we can multiply by -1. And we'll get 0.33 is equal to the probability of H and F. All right. Since this is not equal to 0, so 0.33, does not equal 0, H and F are not mutually exclusive or disjoint. So, quick little FRQ tip in here. Q-tip. Make sure you always answer the actual question. Are H and F mutually exclusive events? You could do all of this work, but if you don't actually finish it by saying they are not mutually exclusive because the probability is not equal to 0, you're not going to get all the credit you should. All right, onward and upward. A researcher publishes an article that describes an association between less recess time and higher incidence of childhood obesity. The article mentions that a lack of sidewalks in some of the neighborhoods studied could be a confounding variable. Explain how the presence or absence of sidewalks could be a confounding variable. So there's lots of different ways to answer this. You could talk about the safety. Maybe those kids are also less active at home. There could just be funding issues in those neighborhoods. It could be a food desert. There's lots of reasons why a lack of sidewalks could be related also to incidents of childhood obesity. So whatever you think of, just make sure you justify it. And this is a good example of a confounding variable doesn't necessarily mean that there's not some relationship between recess time and the incidence of childhood obesity. It just means there's other things that are having an effect. So it's just important to consider it's not always just A and B. All right, 23. If you roll 2 regular fair dice, how many outcomes give a sum of 7? Whenever you're rolling 2 dice, I like to draw a little square. 1, 2, 3, 4, 5, 6. And then again, 2, 3, 4, 5, 6. So this is die 1. And the possibilities of rolling it. This is die 2 and the possibilities of rolling it. And then here are all the ones that add up to 7. This is also useful if you want to do, you can do this with sums, you can do this with products, you can do this with differences. When in doubt, draw it out, right? Always useful to have a visual. So we're not asked for a probability. It just says how many outcomes. And there's 1, 2, 3, 4, 5, 6. So 6. If we wanted the probability, it would be 6 out of 36 because there's 36 different outcomes here. Okay. Use the table to answer the following questions. This is the data from last year's classes, who was taking a foreign language and who wasn't. So what is the probability that a randomly selected student, so student overall, has AP Stats 5th period? So here's 5th period. So this is just going to be 27 over 72. That's it. For B, what's the probability that a randomly selected student has AP Stats 5th period, given that they also take a foreign language at PHS? Okay, given, that is our denominator. So our denominator here is going to be 7. And then in this row, there's only one person in 5th period who takes a foreign language. So that's it. So given that they take a foreign language, 1/7 are in 5th period. Okay. What's the probability that a student takes a foreign language at PHS, given that they are in AP Stats 5th period? So this, we're going to look at it a different way. The given is that they're in 5th period. So that tells me my denominator is the total number of people in 5th period, or 27. And then our numerator is still this single person, because they are both in 5th period and take a foreign language. So it's still going to be 1. All right. What's the probability that a student takes a foreign language at PHS, given that they have AP Stats before lunch? So our before lunch periods are 4th and 5th. So given that they're in 4th or 5th period, so the sum of that, the sum of this is going to be our denominator. And what is that? 56? So we're going to say 56 is our denominator. And so what's the probability they take a foreign language? We're going to add these two. So 5 and 1, because those are all the people who have stats before lunch who also take a foreign language. So that's going to be 6. Okay. 25, I'm going to skip. It's exactly the same as 20, just with different numbers. Okay, 26. At PHS, 7.4% of students have a December birthday. If a random sample of 50 students is selected from all students at PHS, what is the expected number of students with a December birthday? Cool. We're just going to take the percent as a decimal, multiply it by our number, and our expected number of December birthdays in that sample is 3.7. Leave your expected values as decimals, even when that doesn't make sense in context. We are expecting 3.7 students. In reality, we'll get 3 students or 4 students, but this is still what we're expecting. Okay. Speaking of expecting, now we've got our expected value question. So you play a game at the fair. It costs $2 to play. So right away, I'm going to say -2 plus. You have a 70% chance of winning nothing. So 0.7 times nothing. And a 20% chance of winning $2. So 0.2 times 2. An 8% chance of winning $5. 0.08 times 5. And a 2% chance of winning $20. 0.02 times 20. How much do you expect to win? So I'm factoring in that it costs $2 to play because that might change our calculations. So pop that in a calculator, and I believe it comes out as negative $0.80. So even though the expected winnings would be about $1.80 if we just did this part, because it still costs $2 to play, we have to take that out and know that ultimately we're expecting to come out at a loss here. Okay. Almost there. A least squares regression line for predicting NBA player height in inches based on weight in pounds is the predicted height is 66.74 plus about 0.05 of the weight. Kevin Durant is 6'10 and weighs 240 pounds. What is his residual? And then what does the plus or minus sign mean in context? So first things first, we need to convert this height to height in inches. 6 feet, 10 inches is equal to 72 plus 10 inches, which is equal to 82 inches. Okay, so that's his actual height in inches. Based on his weight, we would find the predicted height to be 66.74 plus 0.0573 times 240. And so Kevin Durant's predicted height, 0.0573 times 240, is 80.492. Residual is always value minus the predicted value. So our actual value is 82. We're subtracting 80.492. And we get a residual of 1.508. So this is the residual. And the fact that it's positive means Kevin Durant's height is greater than the model would predict. If we had a negative residual, that would mean his height is lower than the model would predict based on his weight. All right. Cool. Last but not least, student has taken 3 exams so far for a class and scored an average of 88. There are 5 more tests this semester. What must the student's average be on those 5 tests in order for her overall test average to be a 90? So anytime you're thinking about averages, remember the average is the sum over the number of numbers. So the first 3 tests had an average of 88. So 88 was equal to sum divided by 3. So 3 times 88 is going to be what's been contributed already by the existing tests. Then we know there are 5 more tests, and we don't know what those need to average out to. ultimately, she's taking 8 tests, and we want the average to be 90. So this is just taking this idea and filling in the parts that we know, and then using variables to represent the parts that we don't. So 3 times 88 is 264 plus 5x all over 8 equals 90. We're going to clear that fraction by multiplying both sides by what's in the denominator. Those will cancel out. 264 plus 5x is equal to 720. 720 minus 264, so we can isolate the 5x. And this part's all just algebra. That's 456. So x has to equal 91.2. We just divide both sides by 5. So she needs to get an average of 91.2 on the next 5 tests, or the rest of the tests for the semester, in order to end up with a test average of 90. All right, cool. So I have only done progress check for unit 4 of A, but make sure you've done the unit 3, unit 2, unit 1, and the assigned unit 4 progress check. It can only help. All right. Have fun. Good luck. See you tomorrow.